Hey everyone, welcome to Class 2 of Course 1, Networking Fundamentals. Now in Class 2 we will learn about the concepts of IP, answering questions like what is IP, IP protocol, IP addresses, and other IP concepts. First of all, for IP we just need to understand that if a device wants to communicate on the internet, it requires an IP address. When the device has an IP address and the appropriate software and hardware, it can send and receive IP packets. Any device that can send and receive IP packets is called an IP host. IP addresses consist of a 32-bit number, usually written in dotted decimal notation. When we are in a network, then we have a unique identification, and that particular unique identification is the IP address. So IP addresses are a unique identification number which we are using anytime we use the internet. Whenever we are connected with the internet, we get an IP address, whether you're connected in your mobile or any other system. So IP addresses consist of, again, a 32-bit number when we are using IPv4 addresses, and when we are using IPv6 addresses, meaning version 6, then we are using a 128-bit number, which we'll get into more here in just a bit. So first, let's talk about packets. A packet is the basic unit of information in network transmission. We communicate in a packet form whenever data is transmitting over the internet. So most networks use TCP/IP as the network protocol, or a set of rules for communication between devices. They fit into the standard model of networking protocols known as the OSI model. The structure of packets and packet switching network allows for fast and reliable data transmission and makes networks like the internet possible. Whenever we are connected with internet, we have a unique IP address and the data is transmitting in a packet form, and that particular packet is transmitting between unique IP addresses. Next, let's cover more about IP addresses. So an IP address is an address used in order to uniquely identify a specific device on an IP network. The address is made up of a 32 binary bit number, which can be divisible into a network portion and the host portion with the help of a subnet mask. The 32 binary bits are broken into 4 octets. One octet is equal to 8 bits. Each octet is converted into a decimal and separated by a period or a dot. Like in this case, you are using an IP address 192.168.1.5, then you are using a 32-bit number. It's a 32-bit IP address. To check your IP address, just go to the command prompt, type there ipconfig, and you will get your IP address. In case you are using a Linux OS machine, then just type in your command terminal ifconfig, and you will get your IP address. So just check out whether you're using a 32-bit number or you are using a 128-bit number so you can know what your network is using. Remember, 32-bit numbers are IPv4. Remember, 32-bit number addresses are IPv4 and 128-bit address numbers are IPv6. So next is IP service port. So the service port interface controls communicate through and is statistically mapped by the system to the service port. The service port can obtain IPv4 addresses using DHCP, or it can be assigned a static IPv4 address. But a default gateway cannot be assigned to the service port interface. The default gateway cannot be assigned to the service port interface. IP service port, as I have told you, we are using multiple ports in our system, and this is the port for IP service. Next is IP Internet Protocol. So the Internet Protocol is a method or protocol by which data is sent from one computer to another on the internet as we are on the internet. Whenever we're on the internet, we have an IP address. Without an IP address, we cannot communicate. So whenever we are connected with internet, we are communicating through IP addresses. So IP addresses or Internet Protocol is a protocol or method through which data is sent from one computer to another computer. Each computer known as a host on the internet has at least one IP address that uniquely identifies it from all other computers on the internet. That's the only reason you are not getting another system's data. In the case that there was no unique identification, then there may be cases where your data would be transmitting to another device and your device would be receiving data from another machine. It's the unique identification that makes it possible to send information to specific machines. IP by itself is something like the postal system. Most networks combine IP with a higher level protocol called TCP, which we will discuss later. So next is IPv4 addresses. These are Internet Protocol hierarchies that contain several classes of IP addresses to be used efficiently in various situations as per the requirements of hosts per network. The IPv4 addressing system is divided into 5 classes of IP addresses. We have 5 classes of IP addresses. All the 5 classes are identified by the first octet of the IP address. First, we'll start with the Class A address. The first bit of the first octet is always set to 0. Thus, the first octet ranges from 1-127. For example, Class A addresses only include IP starting from 1.x.x.x to 126.x.x.x only. The IP range 127.x.x.x is reserved for loopback IP addresses. We have 1 to 127, but we can only use 1 to 126 IP addresses. And 127 is reserved for a loopback IP address, right? In Class B addresses, the IP address has the first 2 bits in the first octet set to 10. That means Class B IP addresses range from 128.0.x.x to 191.255.x.x. It's the first octet set to 10. The default subnet mask for Class B is 255.255.x.x. You can calculate that Class B has 2 to the 14th power network addresses, and 65,534 or 2 to the 16th power minus 2 host addresses. In Class C, the first octet of the Class C IP addresses has its first 3 bits set to 110. In Class A, the first bit of the first octet is set to 0. In Class B, the first 2 bits of the first octet is set to 10. And in Class 3, or C, the first 3 bits of the first octet is set to 110. Here you can see 110. So in Class C, IP addresses range from 192.0.0.x to 223.255.255.x. The default subnet mask for the Class C is 255.255.255.x. Class C gives 2 to the 21st power network addresses, 254. That means 2 to the 8th power minus 2 host addresses. In Class D, the very first 4 bits, here I am talking about the 4 bits of the first octet of your Class D IP addresses, are set to 1110. Here it is 110. Here it is 1110. In Class D, the IP addresses range from 224.0.0.0 to 239.255.255.255. Class D is reserved for multicasting. We use this when we require multicasting host addresses from the IP address in Class D, which does not have a subnet mask. In Class E, the last class, the IP class is reserved for experimental purposes only, for R&D and study. IP addresses in the class range from 240.0.0.0 to 2555.255.255.254. Like Class D, this class is not equipped with any subnet mask, so we have discussed Class A, B, C, D, and E. Next is TCP Transmission Control Protocol. As we have discussed IP Internet Protocol, now we are discussing TCP Transmission Control Protocol. So Transmission Control Protocol, or TCP, is a network communication protocol designed to send data packets over the Internet. TCP/IP is a set of rules and protocols governing communication among all computers on the Internet. TCP/IP is a combination of 2 separate protocols, TCP and IP, Transmission Control Protocol, and Internet Protocol. When we are using a TCP/IP communication channel, as I have told you, we have 2 kinds of communication channels. The first one is OSI, and second one is TCP/IP. When we are using TCP/IP communication channel, then we are using Transmission Controlled Protocol and Internet Protocol. 3 most common TCP/IP protocols are HTTP, HTTPS, and FTP. These are TCP/IP protocols. We will see HTTP first. So HTTP, or Hypertext Transfer Protocol, is used between a web client and a web server. Whenever you are using your browser, you can see HTTP in your URL. In your address bar, you can see HTTP, and it is using this for communication between client and server for a non-secure data transmission. As I said, it is a non-secure data transmission. For secure communication, we use HTTPS. So a web client or internet browser on a computer sends a request to a web server to view a web page. Then we are using HTTP. The web server receives the request and sends the web page information back to the web client. Without HTTP, we can't use the internet, so it's the HTTP protocol. Next one is HTTPS, which I went over very vaguely. So HTTPS is used between a web client and a web server as HTTP, but the difference is HTTP is non-secure and HTTPS is a secure communication. Often used for sending credit and transaction data for other private data from a web client, i.e. internet browser or on a computer. You're sending this to a web server, and you can share your credentials, you can share your credit card numbers and things like that in HTTPS because it's a secure channel between your browser and the server. It uses a SSL technology and encryption, which we'll discuss later. So HTTPS provides authentication of the website and associated web server with which one is communicating. Next is FTP, File Transfer Protocol. So FTP uses the Internet TCP/IP protocol to enable data transfer. This is used between two or more computers. One computer sends data to or receives data from another computer directly. FTP uses a client-server architecture, often secured with SSL TLS. When we are using FTPS, then we are using secure communication. When you are transferring a file, you are using FTP protocol. Next is User Datagram Protocol, or UDP. User Datagram Protocol is a transport layer protocol defined for use with the IP network layer protocol. It is defined by RFC 768, written by John Postel. UDP provides a minimal, unreliable, best effort message passing transport to application and upper layer protocol. UDP and its UDP Lite variant are unique in that they do not establish end-to-end connection between communicating end systems. We will discuss later about the difference between TCP and UDP. So next is ICMP, Internet Control Message Protocol. ICMP is used by error reporting protocol network devices like routers that are used to generate error messages to the source IP address when network problems prevent delivery of IP packets. It is an extension to the Internet Protocol defined by RF7 792. ICMP messages generated by a router R1 in response to message sent by H0 to H1, H0 to H1, and forwarded by R0. Next is DNS, Domain Name System. It is an internet service that translates domain name into IP addresses. Again, we are using IP addresses whenever we are connected with the internet, and this is a system which converts domain name systems to IP addresses and vice versa. Because domain names are alphabetic, they are easy to remember. The DNS system is in fact its own network. If one DNS server does not know how to translate a particular domain name, it asks another one, and so on, until the correct IP address is returned. So domain name systems are used for converting domain names to IP addresses and IP addresses to domain names. So at this point we have finished Class 2 of Course 1. Thank you, and we will see you in the next class.